Welcome, everyone, and thank you for joining us for today's GraphRAG workshop. My name is Samriddhi, and I'm part of the virtual event teams here at Neo4j. I'm thrilled to be joined by Siddhant Agarwal, Tech Community Manager Developer Relations at Neo4j. Siddhant is a seasoned DevRel professional with over a decade of experience cultivating innovation and scaling developer ecosystems globally. Currently leading developer relations across APAC at Neo4j and recognized as a Google developer expert in Gen AI. And we are super excited to have you all with us today. Just a quick note about questions before we get started. We invite you to submit any questions you have throughout the session using the question tab located at the top of your screen. We'll answer as many as questions as possible in between and at the end of today's session. And if you don't get them to all, someone on the Neo4j team will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. So, with that, I'll go ahead and hand it over to Siddhant.
Thank you, Samriddhi. Hi, everyone. Good morning, good afternoon. I'm guessing everyone is based in the APAC time zone, but nonetheless, good evening for those who are joining in outside of APAC time zone. Um, Delighted to do this another round of virtual workshop on Neo4j GraphRAG Python package for the APAC folks out there. Thank you so much for joining in. And with this, let's get started. Let me just share my screen. All right, 1 second. Awesome, thank you. So, before I begin, a quick round of introduction about myself. I'm Sid. I lead developer relations here in APAC. I started my career with IBM as a Java technology engineer, but then for over a decade, I've been doing just community building and DevRel stuff. That's what been my passion, and that's what my profession is as well now. Worked with Google in the past, couple of startups. I'm also a Google developer expert in Gen AI, and I also take care of GDG and GDG Cloud Bangalore groups, if you've heard of them. You can know more about me, just scan the URL, QR code, and then you can know more about me. Well, that's on the introduction. What are we going to cover today? I am super excited to talk about GraphRAG. Of course, do a quick introduction of Neo4j as well. But essentially, we'll cover the grounds on what GraphRAG is. It's a hands-on exercise you can follow along, or you can skip to follow and probably do this later on. It's up to you. Um, the pace would be slightly faster. I won't be able to pause in between. Um, so again, so if you can follow along with the pace, that's good. Otherwise, you can watch the recording as well. The recording of this workshop will also be available, so you can watch it later on at the comfort. But yes, we're going to cover GraphRAG and Neo4j overview. We're going to talk about GraphRAG Python package. Um, Everything is hands-on, so it's all hands-on demos and exercises. And towards the end, we'll share some amazing resources and amazing offers for you. um, okay, so before we jump onto GraphRag and Neo4j, Samriddhi, can you start the poll? Let's understand a bit on the audience. Which of the following best describes your current level of interest in using knowledge graphs and GraphRag for AI readiness? I hope you can see the poll out there. Yes, I can see some answers coming in. Majority of you, we are in the early research stage. 30% say we are considering this for future strategic plans. Okay, the polls have changed drastically. We are actively exploring or piloting solutions. That's interesting. That's the majority of the folks. Um, just curious and have no immediate plan. That's also totally okay. It's always amazing to learn new technology. Let's wait for another 30 seconds before we close the poll and jump on. to our content. All right. Thank you so much, everyone, for sharing your thoughts. Uh, for 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 everyone out there, we the content we are going to cover today will, of course, be a little basic as well, and we'll try to go into the depths. For some of you who have not worked with GraphRAG, they have zero understanding about GraphRAG, so it's going to be uh, like an overview. Will not be going into the full depth of it, but hopefully you'll become a master of RAG and know how to use Neo4j GraphRAG Python package in your applications. Um, with this, let's move on, and we'll just cover a quick intro about GenAI breakthroughs, and I'm sure everyone is familiar with it. There is no trainer around this. We know that you can generate content and code. It helps in improving your customer experience. There's improved data retrieval and automation, predictive analysis. Boost You can boost your creativity as well with those content out there. Enhanced decision making, process optimization, personalization at scale. So these breakthroughs have literally transformed our lives in the last 2 to 3 years, since the time ChatGPT became democratized, and then everyone started exploring how with just a single prompt you can get the information or generate your content, everything. So that these breakthroughs have transformed, but then we of course also know this for a fact that there's still challenges with Gen AI. Even today, with so much advancements, it still lacks enterprise domain knowledge, and that's very very critical. You do not want to expose your enterprise data to public domain, or you don't want to expose your enterprise data to all of these large language models like GPT or Gemini and others. And there's no way to verify or explain your answer. That's also very difficult. So Gen AI is, or these LLMs are generating you an answer, but there's no way to verify or explain these answers. Where is this coming from? How factually correct it is, whether it is referring to a certain source of truth or just some bunch of articles. The articles may be hallucinated as well. They might be having fake information or incorrect information. So all in all, this is leading to a lot of hallucinations even today. Um, and then of course there's ethical and data bias concerns as well. So with these challenges in mind, the researchers in the Gen AI space, they thought, how can we make sure that we reduce these hallucinations? Well, there are a bunch of other ways to reduce the hallucination, but then one of the foremost, which became an industry standard, is retrieval augmented generation, RAG or RAG, whichever is convenient to you. So uh, RAG became an industry standard where the generation of the result, the output by these LLMs is not purely based on what LLMs already know, but they can also add in additional information, which is like a source of truth, and then you append that to what you already asked, and then pass it to the LLM. Now LLM is enriching its response by combining its own knowledge, what the question is, and also the source of truth, the data that's coming in from the source of truth. So putting everything into context now, it gives you a better enriched answer. Now it's a complete answer. It provides you domain specific and relevant responses as well. It reduces your hallucination with verified data, and then the foremost thing, it aids in explainability. You can trace back to the source node where the result is coming from, and that's exactly what GraphRAG in general helps you achieve. So you can probably start with your unstructured data, which could be your converted into vectors, but then you also extract entities out of that vectors, and then you also have structured data and maybe semi-structured as well. So all in all, this entire spectrum of data sources forms a superset data structure for RAG called knowledge graphs. Um, and this is precisely what GraphRAG is, where you not just are having your um, your unstructured data, but you also have structured data, you have semi-structured data. And with the unstructured data, it is not just purely vectors, but rather you can extract entities which will form a separate graph of its own. Vectors are also not lying in isolation; they're connected with each other, so they form a separate um, document graph, and then your extracted entities became like a domain graph. So these two graphs are together, connected with each other. Structured graph is already there, so that also gets connected to your unstructured. So graphs generated from your unstructured data, and then semi-structured can also form a separate graph, and then all three can combine together, forming a bigger knowledge graph, which will lead to higher accuracy. So this is based on one of our GraphRAG manifesto, where where our CTO Philip Ratley has mentioned that um, GraphRAG in general, or using knowledge graphs, improves your accuracy of LLM responses by 54.2%, with an average of 3x better than your structured query language alone. Okay, so this is a bit of an overview on what GraphRAG is, how GenAI has changed the entire landscape. Now, for those who are very new to Neo4j, we just cover a few basic things on what Neo4j is, some of the basic terminology, so that it's very familiar when we jump onto our hands-on exercise. Okay, so within Neo4j graph components, there are essentially three things that that we generally talk about. So first is nodes. Nodes are basically entities in my graph, in my data. So I can say that, okay, there's a person node, and then there is a car node out here that you see on your screen. And then second important graph component is the relationships, and that is super critical. We consider relationships as first class citizen in Neo4j. What are these relationships? These are association or interaction between the nodes, so they connect the node explicitly. So your person node, and you can see between two nodes there are multiple relationships as well. There's a bidirectional relationship of nodes, there's a unidirectional relationship of lives with, between two persons, and then person also has a relationship, drives with car, and then another person has a relationship of owns with car. So two same node with the same node label, but can have different set of relationships as well. And that's totally okay in Neo4j. This is more like a one to many or many to many mapping that you can easily do. Now, the third important graph component within Neo4j is the properties. So these are attributes of both your nodes and relationships, um, including your vectors as well. So these properties are basically a key value pair. So you can enrich your graph. You can add an additional information to your nodes and your relationship types by adding these properties, these key value pairs. For car, for example, I have this brand model, the brand name, model name, this description, this embedding, as we say, as I mentioned, like your vectors can also be stored in the form of properties, and then there is description source link, and then one of the relationship type has a property called since, and then the year. One of them has name, born. So it's not a mandate that a label should have mandatorily specific properties that you define. Of course, you can put some constants over there, and you can say that, hey, these are the mandatory ones, and these are the optional ones. So the mandatory ones need to be there across all the labels, but then the rest of them could be skipped. You can have unique constants. So all of those are easily doable within Neo4j. So that's an like probably like a 50,000 foot view of what Neo4j looks like, or graph theory looks like. We are not doing intro to Neo4j session right now. We are not going to the going into the further into the basics of what Neo4j is and how to use Neo4j. That's for a different session. With this, we'll move on to our um, to our actual workshop content, where we're going to talk about GraphRAG Python package that we have. We'll be doing this all on Graph Academy. It's an amazing platform developed by Adam from my team. He has been working super hard along with Martin and Irina, who has recently joined. And then uh, these folks have been maintaining Graph Academy, a splendid platform where you can access various courses. More on Graph Academy in a while, but with this we'll jump on. So I'll send it this link to access this workshop content in the to Samriddhi. Samriddhi, if you can just share it with everyone. Just a second. Present. Okay, so I've sent in the link to Samriddhi if in case you missed that. But this is the platform. This is the workshop content that we will be running today. Um, a nice content. It's a good hands-on exercise to understand how embeddings works, how vector indexing works in Neo4j. We have various indexings, like not just a vector index, but a full text index as well. How does that work? How do you integrate Python with Neo4j, GraphRAG package, with OpenAI, of course? How knowledge graphs help in reducing hallucinations, and then we'll do a retrieval also. Um, and towards the end, we'll talk about various retrievers that we have as part of the package, and then if we have enough time, then we'll also try to build an application with one of the retrievers. So I'll share the link for accessing this particular workshop content. What you see um, on your screen probably would be this doc link. The doc link has the access to the course, and then it also has the OpenAI API key. Just a note: this API key is valid only till the workshop is live. Once the workshop is over, this key automatically gets disabled. Can't request, do not misuse it. Until then, um, the resources which we're going to share towards the end, you can just skip this for now. So let's jump directly onto this link, and you will land up on this page. So once you're here, I want you to enroll in the course. It's a simple process. If you have already signed up, so it will ask you to sign in with your Graph Academy account, something like like this. So if in case you are on this kind of a page, just a second. So you'll see an option of sign in or register to enroll. So just click on sign in, and then continue with Google or Twitter, LinkedIn, whatever is comfortable. Just sign in, enroll in the course, and you would be landing on this page. Okay, so let me see if there's any question before I jump on. Just Cassandra is similar to Neo4j, and the next one is, can you please provide the short original link, not shortened? Um, Let me just do that again. Where is the link? I am just pasting the direct link for the workshop, and also paste the bit.ly link. Well, it's already there, so you can take a look. Now, to answer this question on Cassandra is similar to Neo4j. Well, not exactly. Cassandra is like a white column database versus Neo4j is like a native graph database. It has some overlap, some similar functionalities. It does work with the big scale dataset, but it's different. I mean, Neo4j is a fully native. It works purely on graphs, so it's a different database altogether. Okay. How do I mark it as answered? Okay, I think it's better to use a Q&A section instead of the chat to answer these questions. Yeah, I'll humbly request to put it in the Q&A, not in the chat. So there's a separate Q&A section. So over there, I'll suggest to put your questions. I'll mark this one as answered. The next question is, what are the best graph traversal techniques for accuracy and speed in GraphRAG point of view? Okay, so I'll skip this question for now because we'll take this question towards the end. We'll be covering up some traversal, so it's probably going to answer over there. I like to understand the usage of entity resolution techniques and which is the best one to use. Again, this is something that we'll cover towards the end. I mean, a little later into the session. Awesome. Thank you so much. With this, let's get started on to our content. So this content, as I mentioned, is divided into two modules. So the first module is where we're going to talk about knowledge graphs, unstructured data, and vectors. So how do you work with vectors, embeddings, and everything. And the second part is where we are going to cover up the retrievers for the package. So the first part also uses Neo4j package, but mostly for the extraction process, but for the extraction of entities and creation of a knowledge graph from unstructured. The second one is where once the knowledge graph is created, how do you retrieve information? So in this one, we're going to use vector indexes to search for similar data, create embeddings, and build a graph of unstructured data using Python and GraphRAG package. So this is what we're going to cover up in this one. So let's go. Um, okay, so the content for this entire workshop is also available on GitHub if you want to use that content. So you can just click on that link and then access the content available on GitHub. So this is already mapped over there. Um, for simplicity and for our purpose, we are going to use this GitHub code space. It's an online IDE and workspace for this course. Um, which will automatically clone our course repository and set up an environment for us, so that we don't have to do anything. We of course need to have a GitHub account to access it via the GitHub code spaces. We also and there's of course a monthly quota as well. So if in case you have exhausted a monthly quota, you might have to remove your previous code spaces if you have already done this exercise or any other exercise where you have used code spaces. So you have to change your sorry remove your code spaces. So um, or the alternate method is to develop on your local machine. Of course you need to have bunch of things set up. You need to have Python installed, you need to have an IDE as well, where you can make edits. You need to set up a virtual environment, and then you have to just do a git clone so that you can clone the repository which I showed earlier. And so all the packages are available in requirements.txt. You have to just change the directory and do a pip install to install the requirements. So that's essentially what you need to do. Of course, the step of set up the environment would be common for both the types of settings. So even if you're developing a local machine, you would have to do the same step, or even if you're in GitHub code spaces. For simplicity, we're going to use GitHub code spaces. So once you click on open in GitHub code spaces, if you're already logged into GitHub, you will see this kind of a page, and just click on create code spaces. It creates a nice infrastructure setup for us. Loads up the IDE, everything is there, loaded up. It takes a little while for the setup to happen. So while that is happening, let's quickly jump onto our slides and let's cover a few more things out there. Okay, so why Neo4j, and in this entire RAG and GraphRAG concept? Um, well, of course, it leads to higher accuracy and relevance with real-time updates. So Neo4j is a fully asset compliant database. You can add in real-time updates as well. So as soon as the graph is updated, um, your chat application also becomes smarter, or your any of the application becomes much more smarter. So you have higher accuracy, and it's relevant every time when the new information comes in. It of course leads to explainability and governance as well. As I said, you can go back to the source node. You can find where the information is fetched from. You can also put some access control policies onto the node level as well, and restrict some part of the information to some users or to the entire application. So that's also doable within Neo4j. And then of course it leads to accelerated development because we're a truly open source database as well. So whatever you use in the Gen AI infrastructure in terms of your frameworks like your LangChain, Llama Index, Haystack, Spring AI, all of them have native integration with Neo4j. It works seamlessly across the board with the other hyperscalers, your Google Cloud, AWS, uh, Azure, or with any of those services out there. So, and build your own custom UIs. You can use Streamlets, you can use Gradio, whatever is suitable for you. You can use that. Okay. About the package a bit. What this package is all about. So, there are essentially three things that you can achieve out of this package. One is you can build your own knowledge graph. So it transforms your documents into GenAI ready knowledge graphs with vectors. So you have those vectors as well, and then it also extract entities. So it forms a knowledge graph for you, and then you can implement these knowledge graph retrievers. So we have created a bunch of retrievers for specialized tasks. So you can use these retrievers for your based on your application, your requirement, and then you can create your own GraphRAG pipelines, which combines your entire RAG process from retrieval, prompting, LLM with just few lines of code. So it's a very simple pipeline that you can build for your application with this package. Okay. I will skip this. I'll pause this over here instead and then jump to my setup. So you can see over here, this is my setup is almost loaded. And then there is this .env.example file. What I have to do is I have to make a copy of this file and rename this to .env. And then there's OpenAI API key in your for URI, username, password. This information is something that I need to fill in. OpenAI API key can be found directly into the document that I have shared. Um, so I'm just gonna copy. Oops, sorry. I'm just going to copy paste from the document, paste it over here. Now for URI, username and password, I have to jump back to my Graph Academy page, scroll down a bit, and you will see the moment you start a new course, um, it automatically loads up a sandbox instance with the credentials already given to you. So this would vary for each individual, and every time you log in, there'll be a different set of sandbox credentials. So you just click on that, and I have to just copy and paste this. I will do the same thing for password as well. Typically, username will remain same for everyone, which is Neo4j, and password changes. So I just had to do that, and that's all. That's all I have to do, and my setup process is almost done, where I've created a copy of my .env.example file, renamed it to .env, filled in the required values, and put in my API key. So that's all done. But I need to test my setup by running this test environment.py. This is just to check whether everything is okay, whether my instance is correctly started. It is connecting well to Neo4j sandbox. It is connecting to the OpenAI API key. So if all the connections are fine, I should be able to run everything. All right. So just to be double sure, I am also running the requirements.txt file. I'm installing all the packages just to be double sure if everything is installed or not. Usually it happens automatically, but I'm just doing it again. So everything is installed, so all the requirements are satisfied. We are all good. Now we will just run this test environment.py file and see if everything is working fine. Okay. Oops, I don't know. Something has got stuck over here. Okay, while that is happening, we'll come back to this. Hopefully, it should be done in a short while. So this is what we have to run. So we'll run this shortly, and then we'll jump on next. So so next we're going to talk about semantic search, vectors, and embeddings. So generative AI systems often use these vectors and embeddings to represent and understand data. Um, I'm assuming and also hoping that you already know what vectors are and embeddings are. Just for those who are not familiar with this, just quickly giving you an overview of it. So vectors are nothing but a list of numbers, simply put. So for example, 1, 2, 3 is a list of three numbers. It could represent a point in three-dimensional space. I can have similarly 1, 1, 1, which is another point in three-dimensional space. Now, vectors in a Gen AI world, the vectors are not just of one dimension, two dimension, three dimension, but they are of hundreds and thousands of dimensionality. And this is very common, and they use specific set of models to convert your data into this kind of a format. And once they are in this kind of a format, like 1, 2, 3, 4, and based on the dimensionality you have, it basically represents the type of data, including the text or your images or your audio. So that's what these numbers basically represent. Now, in the context of machine learning, NLP, Gen AI, we, we use embeddings and vectors synonymously. So simple way it's a simple way of mapping your complex data, like your words or sentences, into vectors. So that's what embedding is all about. For example, apple as a word could have an embedding which will look something like this, and maybe bigger than this. So this is a way embedding model would convert apple to this kind of a word, so that when you're trying to search for apple, it will search for this kind of, or something similar to this kind of numbers, right? So as I said, there are specialized machine learning models that are used to generate these embeddings for words and phrases in a particular language, and they train a large amounts of data, a vast amount of data to represent each word, each phrase. So everything has a meaning, so that it doesn't loses its meaning across the dimensions, and the meaning is still captured, and that's what we call as semantic search. Now, semantic search is not very similar to your um, control F, for that matter, or what you use to get like a keyword search, where you're looking for exact keyword reference, but you're looking for somewhere nearly similar, which have contextually similar meaning or semantically similar meaning. So that's where semantic search came into picture, where you're not just exactly searching for exact keywords to be there, unlike a traditional keyword search, which is dependent on your exact match keywords or your proximity based algorithms, but you're rather using a semantic meaning of it. So for example, if a user query is like Apple iPhone, it will likely to return result about Apple's iPhone, despite the fact apple apple is a fruit, and then it will be on the same in the same space as other fruits. But we are searching for apple iPhone, so it will look at it as a combination of apple iPhone and create a separate meaning out of it, to give you a semantic search. And that's what semantic search is all about. But how are vectors used in semantic search? They use something. So there are two methods. One is the Euclidean distance between the two vectors, or you find the cosine angle between the two vectors. Cosine similarity is the most common one that is used for finding the semantic similarity between two vectors in comparison to the Euclidean one. So that's what semantic search and embeddings and vectors are all about in a nutshell. Again, as I said, we are not covering up into the depth of it. I'm hoping everyone would have a basic understanding of vectors and embeddings are. So let's move on to the next one. And just before that, let's quickly check. Yes, our setup is done. Let's do a quick wipe. We missed a step earlier. Test environment.py. Let's see if everything is working fine. Guess it ran for 5 tests in 3 seconds, and everything is okay. So we are all good over here. So we are all set. We can execute the rest of our things now. Now the sandbox, once you if you recall, I mentioned that the sandbox is created. So once you start a sandbox, it contains a sample of 1,000 embeddings for movie plot. So this movie, which will have titles, it will have a plot, it will have a bunch of other information as well. So what we have already done, this is at the time of loading the sandbox, that it not just loads up the movies and the plots, the titles and the plots, but it also loads up the embedding. So this would save in time, and because it consumes a lot of API calls, LLM API calls, and also it is a time consuming operation. So we already created these embeddings, and once the embeddings are created, we can load them directly into a Neo4j database. Okay, so the sandbox already contains a sample of your 1,000 embeddings for movie plots. So 1,000 movies, 1,000 movie plots, and each of those movie plots has been converting into an embedding. So once I run this query, what it will do is it will return the titles and the plots for movies that have embeddings. So all the movies that have embeddings. So hopefully I should get thousand embeddings, is what I should get after running this particular cipher query. So you can see that it started streaming 1,000 records. Uh, so I'm pretty confident now that that each movie has a plot. There is no such movie which doesn't have a plot. So I'm all good, and I can move on next. So if I have to find the plot for this specific movie, Toy Story, we'll write something like this kind of a cipher code with some filtering process. Now this has given me the description or the movie plot in a plain natural language in English. But if I want to find the embedding for this, what I have to do is I have to use this property. So plot embedding is an existing property within my database which contains all the embeddings. So for each movie, there's a the property called plot embedding, and that has the 1,000 movie embeddings. So if I run this one, instead of getting the natural language plot, I get it in this kind of a format, a list of numbers, right? So this is what an embedding looks like in a real world scenario. Now, we the embeddings are there, but then we also need to create an index on top of these embeddings so that we can query it faster. So there needs to be a vector index that needs to be created to find similar movies on the plot embedding. So that particular index, movie plots that you see over here, is already created with the embeddings. Once it loads the embedding, it also creates a vector index. But don't worry, in the next few slides, we'll also see how to create your own vector index. So if you have to create a vector index specifically, how do you do that? So now if I have to query and find out all the movies that have similar plot as Toy Story. So this is my reference um, movie that I want to find all the movie plots with the similar plot as Toy Story, and I want to restrict the number of results to return to 6, and the embeddings that needs to be searched is this particular property on this particular vector index. So once I run this, let's see the results. You'll see that okay, I got Toy Story. You see there's a title, there's plot, there's score. So there's Toy Story, this is the plot, and this is the score. Of course, Toy Story will be on a higher side. But look at the other results, which says the Never Ending Story 3, The Little Rascals, and Gumpy the Movie, Drop Dead Fred, and E.T. the Extraterrestrial. So all of them have, if you notice, they have kind of like a similar plot. For example, there's a young boy, there's a magical book, and blah blah. Something similar. Friends attempt to sabotage the relationship. I mean, it tries to find the nearest ones and then gives you a result back. So that's how LLM has decided. Okay, these are the results. That's mostly similar to what you're asking for. Now, as I mentioned, the embeddings were already created, the indexes were already created. But next, we'll see how do you create your own embeddings, or maybe just load the embeddings, and um, and then how do you index on top of it. So now look at this example now, where if I copy and paste this over here, this is just a generic example. What we are trying to do is we are just trying to convert this particular text to embedding. We're going to see live how it just looks like in an embedding format. So imagine if this is like an actual text that exists in my one of the documents or somewhere, and I have to convert this into an embedding format. I have to, of course, plug in my API key over here, and I can just put this over here and click on play button, and then it converts that particular text. It could be anything. I mean, I can just change it to, for example, I can just change it to, I am part of GraphRAG Python package virtual workshop, and it will convert this text to an embedding format. As simple as that, right? Now, for example, so in the previous example, we were using Toy Story as a reference, but now imagine if we don't remember the Toy Story plot. We just have a vague idea of the plot, that okay, there's a movie which has a mysterious spaceship that lands on Earth, but I'm not able to recall the name of the movie. So how do I really find the movie plots then, if I don't know the exact movie names and similar movie plots? So I can even give this kind of a vague plot. It will convert this into a vector embedding, which we saw, and then that vector embedding is search against the existing plots. So let's see how it works. I am going to just add in my API key again, and run this. So a mysterious spaceship that lands on Earth, I get 2001: A Space Odyssey, which is pretty good, pretty near. Alien, The Arrival, Conheads, all of them have a similar plot as what I'm looking for. So now I can select the movie that I want to watch. Maybe maybe not the first one, maybe the second one. That's up to me. But you see how you are able to convert the embeddings of a natural language and search against the database. That's what the intent of this particular exercise is. Next, next we're going to create a vector index as well. So so this is how you create the embeddings. But now to create a vector index, we will not, since everything is done, the movie plots already exist. Now we're going to see how it looks at for on a different property. So while movies also have movie titles and plots, we also have loaded 1,000 movie poster embeddings. So each movie has a poster as well. Now that poster is also converted into an embedding format. So for all the 1,000 movies, we have that kind of a poster. So let's run this and see what the poster looks like for Toy Story, which you see in the image as well, down below. But this is actually the poster that you see. Um, Now, uh, how how the embedding looks like for this poster. So again, as I said, the poster URL also exists into the database, which was preloaded. The embeddings is also existing, but we haven't created the index just for the sake of it, so that you know how the embeddings are really created in Neo4j. So the embeddings were not created, but the index was not created, but the embeddings exist. Again, just to save in time and and to reduce the API call. So we already created these embeddings. But now to create an index on top of the embeddings, what to do is just write this simple line: create vector index, put the vector index name, and it put this if not exists, so that it checks whether the vector index exists or not. Do it for each movie, and the indexing will be on top of this particular property, which is poster embedding. So if you recall, the previous one had movie plots as the vector index. Now we have movie posters as the index. So movie plots was on m dot plot embedding, and movie posters is on m dot poster embedding, so that it indexes specific property. And these are additional configurations like vector dimensions. If you recall, you can specify the dimensions. Again, this would vary from the embedding model that you're trying to use. So if your model allows you for higher dimensions, you can change the higher dimension, or restrict yourself with the dimensions that the model has provided. And then vector similarity function, as I said, cosine is the most common one, most widely used. So you specify that, okay, I want to use it, use the cosine similarity compared to vectors with cosine similarity. Now, let's run this and see what vectors exist now. So it added one index now, and now we see what vector indexes exist in my database. So I know this for a fact that there is a movie plots vector index that exists on plot embeddings, but now there's also movie posters that exist on poster embeddings. Um, so we are clear, we are thorough on the fact that there are uh, two indexes that have been created, two vector indexes have been created on two separate properties. Now, let's go on and see how it looks for how it works in a kind of like a image model. I mean, for understanding with images. Um, so if I run this, where I want to, again, very similar example that we ran earlier, that for a specific movie we know the title, I want to find similar posters as this particular movie, babe. If I run this, I get bunch of posters, which you also see down below. So what it tries to do is it tries to find what's there in the poster. So the embeddings, when we generated, they were generated in a way where it tries to find what's happening in the poster. So hopefully it gives you the results very similar. So example, like, I mean, you see there's a uh, big field out there, empty, kind of an empty field, or there are animals. So it generates a similar poster, something similar around it. There's a human, so it probably finds a human in an empty field, so it just starts giving you kind of similar results. I mean, definitely I won't say this is 100% accurate, but then this is nearly accurate results that you can find from vector search or semantic search. Now, how many such poster embeddings exist in my database? For how many movies? So there are 1,000 movies, 1,000 poster embeddings that exist. So we know that only 1,000 are there into my database. So I can change this later on to any other title. I can just say, let's say, Toy Story, and run this. Probably I get different results this time. I get results for movies like Goofy, a movie, an animated kind of a movie. So there's Pinocchio, which is another animated movie. So you see, it tries to find a similar context in that kind of a sense as well. Okay, all right. So moving on, next we're going to talk about full text search. So while semantic search is amazing, it has really changed the way we retrieve information, we search for information, which matches your pieces of text based on the semantic similarity. But sometimes we still need um, keyword search to be there, a full text search to be there, where we're trying to find, okay, what is the name of the actor in the movie The Matrix. We want to be very, very specifically know the actors in the movie The Matrix. So it has to be spot on the Matrix movie. Right? It's very, very specific. Or which movie is set in Tatooine. I want to be very specific. Okay, I don't want anywhere else. I want Tatooine to be there. I want this specific reference to be existing into my database. So that's where full text search comes in, where you want to have those exact words to be there when you're searching, and then the rest of it could be semantic if needed. So full text search, for example, if the query is Oscar winners of 2019, I want to find specifically Oscar winners of 2019. I do not want 2018. I do not want 2020. I do not want 2025. or any other winners of in 2019, Academy winners, or anyone else. I want specifically Oscar winners in 2019. So I need a full text search over there. But then doing a full text search alone may not be too relevant. Sometimes then it will miss out the semantic meaning. So the best way out is, and the most healthy way is, in my understanding, would be the hybrid search, where you're combining your full text search and also your semantic search. So you're doing a combination of two. Now, how do we really know that which results to be given more weightage, whether it's semantic results or the full text search results? That is something that we're going to cover up little later when we are covering up these retrievers. So when you're doing a hybrid search, it does a comparison of how the results looks like in your full text search and how the results looks like in your semantic search, and then give you now fresh results, fresh scores based on a combination of the two, which we're going to cover up in the later lesson. Okay, let's move on from here and move on to the next one. Now, we will create a full text index which wasn't created when we loaded up our sandbox. So full text index, if you notice, is on directly on the plot. There is no embeddings. So full text index, we know it's something similar to like control F. So we're not doing an embeddings over here. So that's not needed. So we just use this particular statement, this cipher statement, which says create full text index, and we put the full text index name that we want, checks if it doesn't exist for each movie and each plot. Just create a full text plot full text index. So it does that, then I can just see show full text indexes. So I know that only one should exist, or not more than one should exist. I do not need embeddings, as I mentioned. We just created this. Now let's see how it works in action. How it really works. So we just query this now. Now I want to find the exact references of this. I do not want to do a semantic search here. I just want to see whether these three words exist in my plot anytime. 1375 Imperial in China. So if I run this, I get the result as Musa the Warrior, and there is 1375 Imperial China. The next one says the last emperor. It has China, but there's no Imperial, no 1375. This one probably has nothing. So I don't know why it gave you that result. There's China over here. There's no 1375, and maybe something else. Oh, okay. Yeah, there was Imperial out there. It's just exact keyword reference somewhere. Yeah, there's Imperial out here as well. So okay, fair enough. So it searches for the exact keyword and gives us the result. That's all it does. But again, as I said, we're going to discover how the hybrid search works, hybrid retrieval works, where we are doing a combination of um, a full text and a vector search. Now, with this, let's move on to the next one, and we talk about the unstructured data. Now, unstructured data is the most difficult part. That's what thing is that because there's no predefined structure. Images have a different structure, videos have a different structure, social media posts have a different structure, your audio files will be different, emails will be different, text files will be different. So you need to find a unified way to understand information that's there in your unstructured data as well. So that's where concept of vectors, of course, is relevant, but then how you use those vectors also you need to understand, and then where the graph plays a role. So graph, of course, are powerful for representing and analyzing an unstructured data, which we will discover in a while. But how do you make sense out of that unstructured data is primarily with the process called as chunking, where you have this large amounts of data, you break them down into smaller chunks, more manageable chunks. And for example, if you have 1,000 pages PDF, each page is converted. Um, each page will have paragraphs. Each paragraph may be divided into multiple chunks, for instance, right? Or each page is divided into smaller chunks, which are easier to manage. These chunks I'll then later convert it into vectors and then stored it into a graph database as a separate graph. Okay, so we will see how it works. So we'll split text into chunks and then we create embeddings. Okay, all right. So so now what we're going to do is we will be using this particular Python file that's there in our workspace. If you recall, we started a workspace which we haven't used so far, but we will be using it now. So we have a file which looks like this. It has a nice big text. Now we want to see how the chunking works and how the embeddings are converted and generated for these chunks. So that's essentially that we will be learning in the next month. So let me jump to our workspace and show you our create an embedded chunks py file. So this is what my Python file looks like. Now, before I run this, I need to add in a bunch of things. So I need to add a logic of splitting text into chunks. How to split these chunks? What would be the chunk overlap? Okay, this, let's say you say, okay, these many characters should be part of one chunk, and then from next it should be this particular these many characters. Now if you see that it's not ending onto the it's not doing a line by line chunking, it's there needs to be some overlap. So for example, the second chunk could start from here till here, and the third could start from somewhere from here and then goes on till here, something like that. So we have to define that logic, and then once we have those chunks, we need to create embeddings from chunks. So for creating the chunking, we use this fixed size splitter. This is a predefined function that already exists in my GraphRAG Python package. We already have this fixed size splitter that's already existing. Now we will be using this splitter, and we are saying that okay, the chunk size is 100, means 100 characters. So take those first 100 characters. That's a chunk one. Now there will be a chunk overlap of 10, the previous 10 characters, and then take the next 100 characters, and then it starts doing the chunking that way. So we'll take this logic and we'll add it to our script. So we define the splitter. We're going to define our chunks. Okay, you use the splitter and just print the chunks. So let's just run this part for now and see how it works and what kind of chunks are printed. Okay, so if you notice over here, this is my first chunk. Now, this is my second chunk, which is taking a bit of overlap from the previous one. And then it defined, this is my second, oh, wait, sorry. This is my second chunk. Then this is my third chunk, and so on and so forth. So I have got my chunks, but these are not converted into vectors yet, into embeddings yet. So I have to convert these chunks into a embedding. So we will use this logic where we are defining an embedder which uses an OpenAI embedding model. So we are using one of this model called Text Embedding 3 Large. This is by OpenAI. Again, if you're following along, you can use the OpenAI key that's there in the database, that's there in the document that I shared at the start. It's also pinned, so you can use that. So we'll be using this logic to create our embeddings on the chunks. So let's run this particular script again, and first it will do the chunking. It will split the text into chunks. Now for each chunk it will create an embedding as well. It's a pretty long text output now, but then if you see over here, it starts from here and it starts generating some embeddings. Must end somewhere for each chunk. I mean, these are large numbers. It's literally impossible to do it manually for those many chunks. But yeah, um, this is not a single embedding, by the way. This is for each of those chunks. It creates an embedding. Okay, so this is how the chunking and embedding works, but we haven't stored this into the database yet. We don't need it to be stored in the database for now. Uh, Oops, I think I was on the wrong window. Let me just run this again so that you see the chunks as well. Yeah, so this is what the chunks were, and then these were the embeddings. Um, Again, you don't necessarily need to store this entire information into your database yet until you really need it. So for our exercise, we do not need to store them now, but it would make a lot of difference once you store them into a database. Right now, it's just into the memory for now. Okay, next, moving on, we'll talk about knowledge graphs. What are knowledge graphs? So, knowledge graphs are very important to give context and grounding to your LLMs. It gives you like a structured approach now, um, instead of the unstructured data that you are using earlier. So, the best way is that from your s- unstructured data, for example, this is source A is my unstructured data, and then I have these chunks which say that okay, the chunk one is coming in from source, this particular source, this chunk two is coming from this source, this chunk three is coming from this source. From each of the chunks, if there's something relevant that I need, I can extract some entities. So from chunk one, I have topic I extracted, so chunk one is about topic I. Similarly, there's another source which is having other chunks, four, five, six. They know that they are connected with the main source. Now, from chunk four, we say that okay, there's a topic I which also has been mentioned in chunk four and also in chunk one. So instead of duplicating this topic I just create just one node, and it connects both. In a way, indirectly, it is connecting chunk one and chunk four. So if I'm searching anything in topic I get information from both chunk one and chunk four, and not just in chunk one alone or chunk four alone. And that's the beauty about knowledge graphs and GraphRAG. In the retrieval process, you're not just getting information which is there usually in the case of vector rag, in a naive vector rag where you probably have, let's say, chunking done, then you have vectors, but then your vectors would be also lying in isolation, and there's no connection between the chunks. There's no connection between the entities, so it misses out that okay, this particular topic might be referenced across multiple locations, but then wherever it is referenced the most, and probably just from a vector search, it gives you the result, but misses out on the context from other chunks, other other areas where it is occurring. And then similarly, I have topic J, which is from chunk five, and I and J are also related to each other in some sense. So this all in all forms a nice knowledge graph of your unstructured data that you can use. Sorry. Okay. Um, Now, another example of seeing a knowledge graph that could represent Neo4j is that okay, this probably could have existed as a separate graph where I can say that Neo4j is a company, whose founder is ML Ephraim. There's a person who's a person. ML Ephraim as a person also works at Neo4j. Neo4j founded in Malmo location. It's also located in Malmo. It's also located, has offices in London. So this could be probably my separate graph. This could also be like my separate graph. This could also exist as a separate graph. But then if you see, in real world, the data is not siloed. It's not isolated. It's rather interconnected, which we don't realize until we put it in a graph structure. That there's a blog post which is about Neo4j. It's published on neo4j.com. It refers to a documentation. It's published on neo4j.com as well, and it refers to a database technology. So, so yeah, that's how the structure looks like. Okay, so now next, what we're going to do is we're going to build and see how a knowledge graph is built from from ground up. If you have a unstructured data, how do you use that? For that, we have this file called build graph.py file. So let me just jump back and show you. So this is my graph.py file. Now what I have to do is I have to define what's the text that I need to chunk. Um, sorry, how the chunking would look like, then embeddings for those chunks. What are the entities and relationships I need to extract from the chunk? Extract your nodes and relationships. So in the previous one, we didn't extract any nodes and relationships. We just did the chunking process and embeddings. But here we are extracting these entities as well. And then we're creating a pipeline where it stores those chunks, stores those relationship back into my database, and then we run the pipeline. Now, um, uh, if I go back and scroll down below, the chunking the text is pretty much the same. All we have changed a bit over here is this chunk size. So instead of 100 characters, we defined it now 150. Instead of chunk overlap of 10, we defined the chunk overlap of 20. Now to embed the chunks, we use the same logic as we did last time. We define an embedder and we use the same embedding model. Nothing changes here. Now here's the thing where it gets different, where we are defining the entities and relationships to extract. So we said, okay, these are the entities. If you see or encounter references of these entities into the text, or you see this kind of relationship, so it's the LLM's um, understanding of entities, understanding of relationships, and then the potential schema should also look like this: that the person is son of person. The entities and relationships should not be just like isolated. They won't be existing like that. But if you see that the person son of person, something like this is kind of referenced, so then extract all the nodes and relationships from the chunk. So the next one, what we do is we direct the LLM to, we define, okay, there's a GPT-4o, there's the max tokens and stuff like that. We define the configuration, and then we create a pipeline to let the LLM just say that, okay, use the Python driver, use a text splitter, there's an embedder. I've given you the entities, relations, and potential schema. I've told you you have to use the GPT-4o LLM model so that you create this pipeline for me. So you take one step at a time, you create this pipeline for me. And once you run the pipeline will take each of those texts. So I've defined the text now. That said, okay, this is my text. This is another line. So I found some references. I'll create a graph for you now. So once I run this, this package will smartly find all the entities, all the relationships. It will do the chunking, embedding, everything will be done. So you see over here, it's doing the embeddings, chunking is done, embedding is done. It extracted nodes, um, and returned back to the database. Now let's see how the results look like. So if I run this one, you can see over here, this is what my embedding looks like, and you can see this is the main. This is one chunk. Then this is the second chunk. The chunk also has the text. There's an embedding, but then it extracted entities as well. That's how simple the package is. Package will do the task for you. You do not have to write too many lines of code. Just to have to create the pipeline, define what the chunk size and everything is. Okay, that from this chunk it identified that there's this particular node which is a planet, which rules this planet. This house rules this planet. This is what we had defined. Oops, sorry, I was on the wrong window. So this is my chunk one. This is my chunk two. I found only two chunks, um, and that was all my text was. And each chunk has an embedding. There's an text out there that's been converted. This is another chunk which was having another text and embeddings. From this chunk, I found this node, this another node. This is a house. This rules is a planet. And then from the first chunk, we also found there's a person, Paul, who is here of this house. This is coming from this chunk. Now this is from the same chunk. There's Lady Jessica, who is son, who is Paul is son of Lady Jessica. So we defined that relationship as well. So from this text, we have now a better graph which we can easily query. And then if I ask any questions about who is the heir of um, house, this particular house, or um, who is the parent of the heir of this house, I should get, let's say, Duke or Lady Jessica, for that matter. So this is how the chunking and embedding and then entity resolution works. You can play around this. You can create vector index on the embedding property of your chunks, use other cipher queries to search for this property. So all of this can be done easily. But we'll see the retrievers in a while. All right. So this brings us to the end of module one, where we talked about how to use vector and full text indexes, how do you create embeddings and vector indexes, and then building a graph of unstructured data using Python and GraphRAG package. Um, Next is pretty interesting, where if you already have a graph, unstructured graph, how does the retriever works now? Or even if you have the data stored in a graph format, how do these retrievers really play an important role? Um, so, okay, before I jump onto this module, let me just quickly pause and take up a few questions. Okay, so let me start from the top. I like to understand the usage of entity resolution techniques and which is the best one to use. Let's take up this one now because we covered up entity resolution just now. So I'm not sure if it got answered, but just for the sake of it, so the usage of entity resolution is primarily to create a separate domain graph or an entity graph, which can be further enriched with more information. So this domain graph can really help you find specific answers. And then if you're not able to find an answer, or there's a reference from multiple chunks, reference of that entity in multiple chunks, you're not just using one chunk as a reference. So this entity resolution helps in that way. Now, which is the best one to use? I mean, it depends on you. There's no hard and fast technique that this is the best way. It's mostly the LLM's way of understanding how the entities look like in a textual format. Okay, I hope this is answered. I'll mark this as answered and move on next. If you still have questions, just put it in the Q&A section out there. What are the best graph traversal techniques for accuracy and speed in GraphRAG point of view? So this is something which will be getting answered in the next module. So since it's all about traversing, we are yet to cover the traversing in this section. So hopefully this will get answered. The next one is, do I need to create an account to get OpenAI API key? Well, for this exercise, until this workshop, until I'm there on screen, you do not have to use your own API key. You can skip that. You already have the OpenAI API key, which I've provided. But after the workshop is over, the API key gets disabled. So you definitely need to create an account to get your own API key. Alternatively, you can test it out with any local LLMs as well if you want to. I haven't tested that, to be honest, but I think it should work fine. So just check the documentation once on GraphRAG Python package and see if it supports local LLMs. I think so. I mean, that should not be a big deal. Yeah. Okay. So the next question is, few years back, Neo4j introduced concept of graph embedding. I believe embedding in this context of GenAI pertains to embedding from models like text embedding ADA. Just curious, what is the difference of applicability of graph embeddings in this graph, right? So Mangesh, yes, you're right. We introduced graph embeddings, or we call them as node embeddings. Those are different than the embeddings that we're talking over here. These are vector embeddings in general. Um, just for the sake of it, and I don't want to confuse folks out there, so I would skip this question over here. The node embeddings are different than the vector embeddings, so I would definitely recommend you can post this question on community.neo4j.com so that someone on the team can answer it. But you can also find that information on other sources. I'll just send you a quick reference material that you can use for node embeddings. It's basically like a vector representation of nodes within a graph, not specifically on the property, but for the entire node in itself. And this is part of the graph data science. Again, that's why I said I don't want to confuse the um, other attendees. So I'm just posting this in the chat for now. You can copy it, you can use it later on, but this is what node embeddings are all about, in comparison to your um, vector embeddings. Vector embeddings are just on the specific text. And but do post this question on our community forum if you want to get a detailed answer. Um, It's community.neo4j.com, and you'll get a better detailed answer over there. Okay, moving on. Next, connection is not working with Neo4j. That's strange. It works fine. Just try to refresh your browser window once, and you should see the sandbox credentials. And that's why I recommend to also kind of um, uh, do the the test environment file so that you know the connection is established well. So just check on that once. Okay. The next one is how to create embeddings for the plots. Uh, so Kaushik, as I mentioned, like we are not specifically covering up how to create embeddings for plot for each of those plots, but I think in a way we have showed in this particular creating embeddings exercise, where how do you create plots embeddings. So someone in the back end who has designed this particular exercise has already done the hard work of taking each plot, converting into an embedding, and then storing it probably as a CSV or something else. And then once the sandbox is created, it automatically loads up. So you can do the you can use the same function to create the embeddings and then run it like one after another, like for each of those movie plots, and then do it on your own with your own API keys. But we just for the sake of it, we for this particular workshop, we didn't cover that specifically on how to do it for each movie plot. Cool. I hope it got answer. Moving on next, how can we extend a cipher-based RAG pipeline originally designed for simple single-hop queries to handle complex multi-hop questions that involve complex reasoning, aggregation, comparison, schema understanding, etc. That's a very good question, and I'll skip this for now because this is also getting covered up in this module most likely. But if it doesn't, then you can just let us know. Let me know. The next one is chunks may disconnect the sentence continuity, right? How it handles. So, good question. So, if you recall, we also talked about chunk overlap. So, that discontinuity is overcome with this chunk overlap so that there's no discontinuity. One. The second thing is in your naive vector RAG, the chunks, irrespective of the chunk overlaps, they're still disconnected. With the GraphRAG, since the chunks refer to each other as well, they are also connected in some sense. So there is a chunk overlap, and then the chunks are also connected with each other. You see, this is one chunk, zero chunk, and then there is next chunk. So there is an overlap already in the text, but then the chunks are also rather connected with each other now over here. So there's a one chunk, and then this gets connected to another chunk. Okay, moving on to the next question. How do I determine the chunk size and chunk overlap? Well, there is no standard mechanism, to be honest. I mean, it totally depends on you. Ideally speaking, what everyone recommends is that you do not have too big of a chunk size, have smaller chunk size. There's no direct way, to be honest. It's up to you. You can play around with it, various chunk size and chunk overlaps. But in my understanding, it totally depends on you. There's no immediate answer to it. So uh, play around with multiple chunk size, chunk overlap, see which one works best. Um, and if you're not getting enough results, then maybe just increase the chunk size. Why they do not suggest to have a bigger chunk size? It's kind of like you're saying that I've increased the context length window. So that's why it's not it's not recommended, to be honest. Yeah, I mean, maybe 100 characters or 150 characters may be small, so you can of course increase it to a bigger chunk. Is there any pros and cons to changing the sun size? I think I just covered up this part. So I won't say there is any con as such, but yeah, I mean, of course, there's a con in terms of if you have a way too big chunk size, then you're essentially just utilizing the context window, and then you're just putting everything into it, which doesn't make sense. You should have it smaller one, so that it's easier to understand and you can extract more entities out of it. Okay, so the next one is for a very large new document, 5,000 pages, where we have no clue about the schema. What are recommendations? Okay, so GraphRAG Python package, to my understanding, needs a potential schema to be defined. May not be the exact one, but there's another tool, which again I'll not cover up now. I'll also not mark this question as answered for now. So there's another tool that can take up the schema on its own, which I'll cover towards the end. Are you going to cover ontology over knowledge graph? Well, not this particular workshop is not about the comparative analysis on that, so I will not be covering up that part for this particular for the sake of this particular workshop. Just a second, just need to grab a bit of water. Okay, in a demo now, we define a schema based on our toy data. In reality, the data is huge with so many tables, pics, etc. How do we practical tackle such huge dogs? Make a schema. Challenge: we do not know anything about the intricacies. And the document no domain knowledge. Content is long and it's impossible to know all entities or relationships in advance. Suggest a style. That's a good question, very valid question, and it also is related to your previous question as well. So um, allow me to finish the next module, and then after we are done, I'll show you how do you handle this kind of a situation. Okay, is chunk similar to word or token? Not exactly. Chunk is like a piece of text, like couple of lines maybe. um, it's a bit different over there. Okay, the potential schema defined example are just few examples and should be exhaustive. Yes, this is exhaustive. So I will mark this question as answered and keep your the previous one there, and mark one of your previous one also as answered, um, so that I don't have too many questions out there that I have unanswered. The next one is, does each of the chunk generate separate embeddings? Yes, so each chunk will have a separate embedding as well. So for example, if I go back and run this one again, there's always connection issue sometimes. Hmm. Example, this is one chunk, and this particular chunk has this text, and then it has an embedding. Now this chunk has different embedding and different text now. So yes, chunk have separate embedding. Each chunk will have separate embeddings out there. Is there a prompt behind the screen extracting entities? Can we access the prompt and make changes? If yes, domain specific prompt as a library. Again, all of this question, Arun, you have. I know that these are really pressing questions for you, but allow me to finish up the next module, and hopefully these will get answered as well. So I'm marking this one as answered for now, because the tool that I'm going to talk about towards the end can help you achieve all of this. Okay, so we are running out of time. We need to quickly jump on to the next module. The next module is going to be fairly easy and quick and simple. So we're going to talk about various retrievers that we have as part of this Neo4j GraphRAG package. So we have 5 retrievers in total. We have vector retriever, there's a vector cipher retriever, there's hybrid retriever and hybrid cipher retriever. And then the fifth one, the last one, is the text to cipher. Now let's go into the depth of each of those retrievers and why and how they are useful, and when are they useful, so that you have a better understanding. So RAG, we already know what is RAG all about, retrieval augmented generation. So I'll skip this part and move directly to the next one. This RAG is something which we have been covering up since the start of it. Okay, so what does a vector retriever do? So vector retriever basically just does a vector search. Simple enough. Just in plain simple words, it does vector search. So in our workspace, if you go to the second folder, which is Neo4j GraphRAG, you'll see this vector retriever. Um, I'll just clear this up. Now, in this particular one, simple process, we initialize the embedder, initialize the vector retriever, and it retrieves. Now, what information that needs to be added? I'll just add this over here, and then there is the retriever. So this is my embedder, this is my retriever looks like. So I have to define an index name. So I have to retrieve one movie plot, so I can change this retriever. So for each, so if I probably am doing for movie posters, I might have to add a different vector retriever for that. I have to create a separate retriever. So this will just do it on movie plots, and it returns title and plot properties. Very similar to what we have done in the previous one, but now we are doing it with the package. Okay. So if my text says give me three films where a hero goes on a journey, I don't know the movie name, I don't know the title. You recall where we are converting this something similar, where we had this mysterious ship lands on Earth. We converted it into a embedding. The embedding is search against the existing embeddings that are there in my database. So that's the same thing that's happening over here. Um, but instead of writing a cipher code, we are running everything via our package. So all of this is what we are running it. Just for the simplicity, I'm just putting it over here. And once we run this, once I run this, it should give me three films where a hero goes on a journey. So the previous results that we saw on our Graph Academy page in the previous one, those were not uh, well generated, in the sense that there was missing things, like, I mean, it was not summarized well. That's what the LLM practically does. It summarized it also, that says, okay, instead of just throwing it directly as a title and the plot, it just said, okay, this is the movie, this is the title, this is the plot, in a nice fancy way, basically. I mean, vector retriever is nothing but just a vector search, simple vector search. I just want to get three movies where a hero goes on a journey. That's essentially what we did. Now, the next one is where now we know that, okay, we have got these three movies, but we don't want to find the movies. We said, okay, give me the actors in the movie where the hero goes on a journey. For instance, I do not want um, the movie names. I just want the actor names. Now our movies also have a connection with actors. Okay, an actor acted in a movie. So I have that as a structured information that exists in my graph, but I haven't disclosed this earlier to you because it won't make sense, but it will make sense now. So I know there's a movie Jumanji, and then there is an actor also that acted in the movie. So for the movie Jumanji, I know these are the four actors that I have. So now these four actors have acted in the graph, in the movie Jumanji. Now, if I'm not able to recall the name of the movie, I just know the vague plot, and I want to find the actors, not the movie, based on the vague plot. So what I can do is I can just instead say that find me the actors in the movie about the Magic Jungle board game. So I know that Jumanji was about a Magic Jungle board game, but I don't want to know the name of the movie. I want to know the name of the actors. So that's where vector cipher retriever comes in. Very similar to what we did in vector retriever, just one additional step that gets added. So once it finds the source node, once it finds the vector, once it finds the movie that you're looking for, it starts doing the graph traversal. So one of you has asked, like, what is the best graph traversal technique for accuracy? So this is one of the technique as well, where you combining a vector and a cipher. Vector to for the initial search, and then if you already have a structured graph, then it or you have a graph basically. You can do an additional graph traversal, so you can go from one node to another node after identifying the source node. So this is one of the method for that. So if I go to this one, almost everything remains the same except for this part, vector cipher retriever. Now here we have to also define a cipher statement. We have to tell to our LLM that go from the source node to actor node. Uh, so this is kind of a drawback as well. I would rather also say that this is also drawback in the sense that I have to write a cipher code uh, in each occasion, but it would be fine for specific graphs where I have to just go from one node to another node only. So this would be more relevant if I have to have, like, let's say, fine grained access control policies, or I just want to restrict it to just specific information, so it just don't go across the entire graph but restricted to only these few graphs. So I define this kind of a vector cipher retriever. Define this. Okay, this is what my retrieval is. Once you identified the source node, do this kind of a traversal as well. Return with a plot, title, and the actor names. Now let's use this retriever to our advantage, and let's use this one now. So, who are the actors in the movie about Magic Jungle Board game? So, I should first find the movie Jungle Board, Magic Jungle Board game movie, which is Jumanji. From Jumanji, it should go to the actors. Now, okay, the actors in the movie Jumanji, which is about Magic Jungle Board game, are Robin Williams, Bradley Pierce, Kristen Dunst, Jonathan Hyde. Okay, so this is what vector cipher retriever is all about, where you are combining both vector and cipher capabilities. Now, you recall we talked about full text search. We also talked about hybrid search when we were talking about full text search. So hybrid retriever is basically doing a hybrid search, which is a combination of vector and your full text. Now, how does it work? If you see over here, there's a user query. When someone gives a query, it will do it both. It will do vector search. It will also do full text search. But how does it get to a conclusion? Then which one should be given more weightage? Whether it's the result is coming from full text or whether it's coming from vector. So what will happen is vector search, for example, will have three results. Okay, there'll be one node zero point 0.9 score, another node 0.5, another node 0.3. Similarly for full text also you'll have some scores. Now, all of these for a vector search, all each of the scores are divided by the maximum vector search score. So this is divided by zero point 0.9. This is divided by zero point 0.9. This is also by 0.9. And you get new scores now. Same, you do the same thing. So you divide each score for full text search by the maximum full text search score, and you get new scores. Now, once you get new scores for both vector search and full text search, you re-rank them. You find out the top scores based on the top k nodes. So if you have defined top k as 3, you're essentially are having 6 scores now. So from 6 you convert to a 3 scores. So the top 3 scores. So this is one, and then this is another one. So you see the results are coming in more from full text and then one from vector search. So now this is how it picks in and identifies that, okay, I have to pick in full text or I have to pick in vector, or give a combination of 3 depending on what you have defined in top k. So this is what we are going to experiment. Now we'll also see where and in which scenarios this is relevant. So we are going to run this hybrid retriever where I have same thing, initialize the embedder, initialize the retriever, and use the retriever. So we are going to use this embedder. They changed the embedder. We have used text embedding ADA 002 compared to text 3 large that we were using earlier in our exercise. We have been using text embedding ADA 002 for all of our exercises. So we initialize the hybrid retriever. Now One thing to note in comparison to a vector retriever, where we had just defined an index on movie plots, index name and movie plots, we also have to define separately the full text index now. So there's a vector index, and then there is also a full text index. And we just have to use the retriever. As simple as that. Now, what questions would be relevant? The questions would be relevant where we have to find both exact references and also something similar. So I want to find the movie that is set in 1375 in Imperial China. So an exact reference and also somewhat similar movies. So let's run this one now and see the results that come in after this. Okay, so the movie set in 1375 Imperial China is Musa the Warrior, which, if you recall, was the movie as well. So for this particular question, if you notice, the full text is taken kind of on a higher precedence. That's how you're getting a result more from full text rather than from a vector search alone. Okay. Now, very similar to what we did with vector cipher, if we want to not just get the movie name, but rather I want to find the actors that acted in this movie. So that's what hybrid cipher will do. So I know that who are the actors in this particular movie. So let's see the actors that acted in this movie. So there are these four actors that have acted in this particular movie. Okay. Now let's look at how the vector cipher works. So almost until this point, it's it's the same thing until this point. It's almost the same thing with the hybrid retriever. Now, what will happen is that once you've got this, it augments nodes with graph traversal. So for each node, it will start doing the graph traversal and finding which is the most relevant one. And that's what the cipher query will be there. Very similar again to vector cipher retriever. You add in a cipher query and it starts doing a cipher traversal, graph traversal out there. So let's go back to our workspace and go to hybrid cipher retriever, and we will go to initialize the embedder. First, we will initialize the embedder. Same thing, very simple process, what we did earlier. And then we define the hybrid cipher retriever with both the cipher query and also the vector index name and full text index name. And then after that, I can just use the retriever, ask a question like, what are the name of the actors that in the movie acted in the movie set in 1375 in Imperial China. So once I run this, I should get the name of the actors that we saw over here. So these are the four actors. So it should first find the movie, then do a graph traversal for us. So it found that okay, the actors in the movie. So this was a movie. It's set in 1375 in Imperial China. Irfan Khan, blah 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 and blah. So I am pretty okay with this response now that I have got a hybrid cipher response now. Now, someone asked like which is the best graph traversal techniques for accuracy and speed in GraphRAG point of view. Well, I would personally rate hybrid cipher retrieval because it is not just doing cipher, it is not just doing vector, it is not just doing full text, it is doing a combination of three. So, in my personal um, opinion, it would be hybrid cipher. But again, a lot of people just use vector cipher. They do not want to use hybrid cipher. So I would prefer a approach of hybrid cipher instead of anything else. Now, in terms of speed, it would also vary how big the graph is also. Sorry, and how well it is modeled. So that also makes a lot of difference. So there's a lot of room for improvement in a graph, and it can evolve over a period of time. So the technique can also change. So you might start with vector cipher and then switch to hybrid cipher, or you start with hybrid cipher and switch to vector cipher. But this is my understanding. But again, I do not want to bias you with any specific traversal technique. Um, you can use whichever you want to use. I hope this answers. Um, Now, lot of you felt that okay, we have to write a cipher code, which is not easy. But then we made it a little easy to convert your natural language to cipher using the text to cipher retriever. Text to cipher retriever does a simple process of translating a natural language to cipher queries. So we have a specific text to cipher LLM model, which is fine tuned on a foundation model. Uh, so this text to cipher retriever uses that fine tuned model. So if my question is that return the first 25 nodes from the graph, and I pass it on to text to cipher, it converts it to a cipher statement and gives back the result. So let's say if I have this kind of a question like actor acted in a movie, and if I run this particular cipher code, I know these are the movies that Hugo Weaving acted in. So if instead if I have just a question that says which are the movies that Hugo Weaving acted in, it will convert my question into this kind of a cipher statement. Uh, let's look at this text to cipher, how it works in action now. We don't need an embedder, nothing is needed over here. We just have to convert our text to cipher. For that, we need to of course have bunch of information to be added, which is creating an LLM object, um, defining a Neo4j schema, that okay, this is person, there's a movie, these are the relationships that exist, um, and this is how the structure looks like, this is how the schema looks like. And my question is, which actors starred in the movie The Matrix? This is an example question, and give me this question. Give me the it give me this kind of a query, and this query is then passed on to the LLM, or generate an answer for us. So if my question is that which movies did Hugo Weaving star in, once I run this particular this particular script, I would get that Hugo Weaving stars in blah 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 movie. So it's a simple text to cipher. So it starred in the following movies: Guest to Cloud Atlas, Dressmaker, so that you don't have to write your own cipher code. All right, so that's what our fifth retriever was all about. Text to cipher retriever. The last one is the challenge. It's a multimodal application with vector cipher retriever. It's a very simple thing. So with multimodality, how do you achieve multimodality in Neo4j? So Neo4j doesn't support images directly, but there is something called as metadata management, or you can convert those images to text and as an embedding and then store it into the database. That's what we did in the previous exercises as well. This particular application does the same thing. I would suggest you can take this as a challenge, as a test that you can do. So, for example, if I have this kind of a query, find a movie where in the poster there are only animals without people, I can just go from movie to get their posters, and then from posters I can get other movies also. So yeah, so this is the application that I'll leave you to play around. Just have to go to your multimodal app and then update the code. By the solutions and the working solutions for each of those scripts are also directly available in the solutions folder. So this is an exercise for you to take. Now I'll pause over here, and I think we are midway. Sorry, we are almost towards the end of our workshop. Um, Somebody, do we have anything, any offers for now that you want to add in?
Yes, I'm just going to quickly add one offer. I need you guys to give me, if in case you guys wanted to get contacted by Neo4j team. So I'll just put that one in first.
Yeah. So while Samriti is doing that, let me just take up the questions that are there. How can we extend a cipher graph ways? So yes, if you want to set up a conversation with a graph expert, we didn't cover too much content. Unfortunately, this is more for folks who are super new to GraphRAG. Um, if you still need more understanding on graphs, or you need a graph expert to connect, to click on that link and then connect with someone. Um, okay, moving on to the question: how can we extend a cipher-based RAG pipeline, originally designed for simple hop queries, to handle complex multi-hop questions that involve complex reasoning, aggregation, comparison, and schema understanding? Okay, and the next question also I'll cover up together with this, with this nice application, and hopefully, I guess, this is a separate application, although, but the same application is the features of this application probably are also getting added um, to Neo4j GraphRAG Python package, which do not exist for now, by the way, just to be clear. But you can do the same thing. The so I'm just giving an intro of the tool, and hopefully this answers both of the questions. If not, then you can just add in your specific question. So what this tool is, this is a Neo4j LLM graph builder tool which extracts your nodes and relationships from your unstructured data. I'm going to paste this link in the chat window as well. Uh, or rather, I'll send it to you, to somebody. Somebody can just add it to the chat window or publish this. So this tool, in a very simple way, it connects to Neo4j instance, any of your Neo4j instance. It could be a blank instance as well, like it doesn't exist. There's no data that exists in Neo4j. You upload your file, your unstructured file, and then you click on generate graph. Now we have hosted this as an online application. The online version, when you access the online version, which looks something similar to this, will give you specific LLMs where you do not have to plug in any API key. So you use 4.1 or 4.1 mini, or you use the Gemini 2.5 Pro, DevBot, Plot4 Sonnet. So you don't have to provide any of the API keys. Once you do that, once you select any of the LLMs that you want for processing, what it will do is it will take each of your document. It will create two graphs. One is your domain graph, and another one is your document graph. So document graph is nothing but your document into chunks. Chunks are connected with each other. That's your document graph. And then from those chunks, it extracts entities, and that's your domain graph or an entity graph. And these two are connected with each other. Now, I don't know. It takes a little while to just come up. So this is the same functionality that is soon to be going to be added to GraphRAG package. But for now, if you want, you can use this tool. You can read more about the tool while that's loading. I'm just quickly show you the tool. You can read more about the tool. There's a bunch of blog posts that are also written about how the functioning works, how the backend architecture looks like. It's a fast API that the team is using. It's a I think it's a React front end that they have built. So so if you see over here, there's a document or a chunk. So this is what my document or a chunk. So this is my PDF, which was titled as 6.pdf, and I got multiple chunks, and these chunks are part of the main chunk as well, and also there's the next chunk, there's next chunk, and so on and so forth. And then there is entity graphs also, where I am extracting entities out of each of those chunks. So from this main document, each chunk will have some entities, and those entities are connected with other chunks, and so on and so forth. Now the beauty about this tool is that I can add in some graph announcements as well. So one of you asked, like, if I want to handle, if I already have a structured graph, so you can use that as a schema. So once you connect to a database, before you start doing the processing, you can select the schema as well. You can use that as a reference point. You can say, okay, just use this as a reference. Do not go outside the schema. Or you can be open. You do not define any of the schema. So you can either load the existing schema, which will fetch from the database. You can get the schema from the text. You can give a sample text. Um, there are some predefined schemas also. So if for basic use cases like movies, healthcare, we define some schema. So you can use this as a reference. So once you give a new unstructured document, and if the LLM finds this kind of a potential pattern, um, you can of course change even in this. You click on apply. If it finds this kind of a potential pattern, it creates a graph for you. So what will happen is now your questions are not just single hop queries. Your questions become multi hop questions. So you have your domain graph, you have your document graph and everything, and then you also have your structured graph. So now you're getting better and accurate results with this kind of an approach. So this so once, and as I said, like if you keep it blank, there could be a possibility there would be some disconnected nodes or orphan nodes. You can delete those as well from the tool, or you can go back to your Neo4j instance and delete from there. There could be a possibility that same node would have been created twice. You can do a deduplication of nodes. I mean, sometimes it creates, um, for example, India could be mentioned as IND, IA in one location, IND in one location, and IN in another location, which essentially means um, it's a country India. It's referring to country India. So you want to club them together. So you can merge those duplicate entities as well within tool. Again, I this is a little out of scope for this particular workshop. I didn't want to cover this one specifically, but since you folks asked, this is what the tool is all about and helps you in achieving. um, so go and check this tool. If you have more questions about the tool, I would still suggest to go and put in community forum. As I mentioned, this is outside the scope of this particular workshop, but still, if you have any questions, you can put on community forum. So marking these two questions as answered, I hope this gets answered as well. If you still have any doubts, just put it in the Q&A. The next one is, I'm still not clear how I'm going to use this in enterprise solution and which area. Well, there's so many enterprise use cases for GraphRAG. Uh, I might have a slide that I can just quickly show you. Just give me a second. Let me just try to locate that slide. And hopefully that will give you a little clarity in terms of the use cases. But again, just don't restrict yourself with those use cases which I'm just showing you now. These are just some reference ones, like enterprise knowledge search. You have a knowledge repository. You can use entire knowledge repository to be converted into embeddings and extract entities and then store it into knowledge graph. Customer service as well. You want to refer to past customer tickets, everything that happened in the past, and then make sense of what's happening. Ticket triaging, of course, recommendations, news, content and discovery, FAQ boards, patient prioritizations, clinical decision systems, support systems, pharmacovigilance, health assistance. Again, these are just limited ones that I could list over here, but um, you can of course go to any depth. Okay. Next question is, how can we perform community detection here? What's the simplest way to get started using built-in algorithms like lead-in, and how can we interpret or use the output during the retrieval stage? Again, this is outside the scope of this, but just to let you know, once you use this tool, it automatically creates communities as well. It is not showing up here, but in general sense, when I mean, because these were processed long back. This is, I don't remember, I think probably a year back. But if you process now, you will also get communities that's there. And another thing option is that you can use the local version of this tool, which is much more powerful and has more features. So this is available on this GitHub URL. I'll send this GitHub URL also to Samriddhi. Samriddhi just added to the over there. So it supports more LLMs. So if you want to test out with local LLMs, your own LLM API keys, you can do that with a local version. Um, yeah. Uh, yeah, this is just follow the steps, follow the method out there, and then it does the community, creates those communities on its own and you can do the community detection. Other than that, as you mentioned, there's lead algorithms as well. So we have a lot of algorithms for community detection as well within Neo4j. Again, this is not something which is to be covered up at this part, but you can go back and read more about um, graph data science. So graph data science is something where you have these algorithms that exist as part of community detection. So we have this entire library of tools that you can explore. Cool. The next one is the cipher retriever. Is there any way of tuning or using separate retrieval queries depending on the search question asked? Uh, so you might have to create bunch of retrievers. So that is something which is missing right now as part of this retriever, where you have to create multiple retrievers for each use case. But yeah, I mean that's doable. If you have limited use case and you want to implement each of your own retrievers, you can do that. Or alternatively, another approach could be, just don't quote me anywhere, but yeah, you can use the logic that exists in this LLM graph builder tool, because this graph builder tool, if you notice, is a chart mode as well, which is vector, full text, graph plus vector plus full text, and entity search. So based on the mode that you're selecting, it automatically generates a cipher query also at the backend. So yeah, I mean, a lot of work to be done, but yeah, that's another alternative. Could we combine DexoCipher with hybrid retriever when we need to avoid manual cipher but need leverage of vector and full text? So I think that's doable. You should definitely give it a try and share your experience with us. I haven't tried this myself, but yeah, I would love to see how you would be able to combine DexoCipher with hybrid retriever. I think that should be doable. The tool is great, but if we need to use it the SDK way, can you please do so? Yeah, I mean, there is no SDK as such, but you have to deploy your own local version. Just run these steps and deploy as your separate front end, back end. So there's no other alternative for now. Okay, the next question is: as the LLM graph builder is open source, how can we change the prompt for the graph generation? I think this is something which I already covered up. You have these graph enhancement options where you can um, select your patterns. You can change how you want the graph to be generated. How do we enforce an ontology on a document content that is getting uploaded? This question is out of the scope of this workshop, so I'll skip this one over here. I'll mark it as answered, but I will request you to post it on community forum so that you get a better answer. Again, ontology is outside the scope. I don't want to confuse the rest of the folks, so I'll skip all the questions on ontology this time. Okay, I have done PhD in ontology, RDF graph, how to make career in Neo4j. I've checked Neo-semantic plugin. For careers, the best way is to go to neo4j.com/careers. That's the only option for something that I know of. Okay, so yeah, that's pretty much. Let me see if there's anything that I'm missing. Yeah, these are some resources. You can check upcoming events, these free courses, detailed blog posts. All of them are already added in the document as well, so you can check those documents. And as I mentioned, the key will be disabled. So make sure you plug in your own API keys if you want to reuse the workshop content. So you have to plug in your own API keys. But yeah, that's pretty much about it. Um, if you have more questions, I will suggest you to post it on community.neo4j.com. And with this, I'll hand it over to Samriddhi. If you have any more things, any exciting offers, any more resources for folks.
Thank you, Siddhant, for this wonderful presentation. Just wanted to let the folks know that Notes 2025 is back for its seventh year. Don't forget to register. I have already published the link for it. Also, I would just love you guys to send us a feedback. That is also something that I'm just putting it over here as an offer. All right, then. Thank you, Siddhant, for such a great workshop. And for those in the audience, thank you for joining us today as well. Wish you all a great day.
Yes, and just a quick note towards the end. There is Graph Academy where you have more of these courses. Don't forget to take up other courses on Graph Academy. A lot of content on GraphRAG is coming up. There are free certifications. Take them up as well. And last but not the least is a shameless plug. To grab a copy of this book of mine, which is launched recently. Um, it's on building Neo4j powered applications with Langchain4j, Spring AI, and Haystack. Three of the frameworks is what we covered. Um, I shared the 25% discount code as well. If you're interested, just grab a copy of yours. Awesome. So yeah, that's a wrap. Thank you so much for joining us. And I'm sorry if I couldn't cover up most of the questions. But you're always free to post them on our community forum. Thank you.